Hello everyone, today let's take a look at Quantipose number 14, which is another visualization type of brain teaser where we have this 8x8 chessboard with the two squares along opposite diagonals removed. We also have 31 bricks with dimensions 1 by 2. So can you place these 31 bricks such that the entire chessboard is covered? So now I just roughly drew out the setup. These lines aren't exact, but you get the idea. These are all equal length. And here's our chessboard. You can see that these two corners have been removed. And here are our bricks. They're size 1 by 2. We can either place them like this on the chessboard or we could place them vertically. And we have 31 of these bricks. Now note that given an 8x8 chessboard, that would have had 8 times 8 pieces, so 64 pieces, but we removed the two corners, so now we only have 62 pieces on this board. Well, now your first thought should be is that I have 31 2x1 bricks, and I need to fill in 62 squares, right? 31 times 2 is 62. So obviously I should be able to fill these in. What you'll notice is that if you actually try to do it, like let's say I go here and then I do one here and I put another here, well, it's going to get awkward because this isn't available anymore. So I have to go up like this, and then it's just going to get awkward. And eventually when you get to the end, you'll find that no matter what you do, you always have your last square looking something like this going off to the side. It's not possible to actually do it. So how would you know that you can't do this without actually filling in every single block? Essentially, the trick to thinking about this is that we want to color the board like an actual chessboard. So this is what a chessboard looks like when it's all colored in, and essentially what we see is that on any given edge, none of the same colors are touching each other, right? If I have a black, it's surrounded on all sides by white, and if I have a white, it's surrounded on all edges by black. Now, how does this help us answer this problem? Well, imagine one of my blocks, right? It's a 2x1 block, so I have 2 bricks, and I place my first brick in, let's say, this square, right? Then no matter where I place the second brick, no matter what orientation I have the block, if I do it here, it's going to have another block of a different color, right? Because every block is surrounded on all sides by the opposite color. So if I place my first block here, let's say, my next block's going on white. If I place my block here, the other one has to go on black. Now notice that the two corners that were removed in this case were both black, right? This one would have been black because it was surrounded by whites, and so would have this one. So now because we removed 2 black squares, that means that we only have 30 black squares remaining, and we have 32 white ones. Now, since I only have 31 blocks, and each one of them needs a white and a black square under them to be placed, I'm not going to be able to place all 31 of these because I'm limited by the number of black squares. You can see that once I place 30 of these blocks and I'm only left with 2 white squares remaining, well, I'm not going to be able to place them, obviously, because if you look at this board, you know, there's no 2 white squares that share a border. So therefore, I'm only going to be able to cover 30 times 2, which is 60 squares, right? I cannot cover all 62 squares, and that answers the question.